Hi guys, welcome to my channel. In this video, let me explain the syntax directed translation for assignment statements. Syntax directed translation or SDT is an important concept in compiler design. It helps the compiler to translate the source program into an intermediate representation by associating semantic action with grammar rules. In this presentation, I will explain how SDT works specifically for assignment statements and arithmetic expressions and how it generates the three address code. Let's see the agenda. First, I will introduce the syntax directed translation and explain what an assignment statement is. Then I will explain the grammar used for assignment statements and how semantic actions are added to that grammar. After that, I will discuss the expression evaluation, type checking, and intermediate code generation. Finally, I will work through some examples and explain the advantages, applications of SDT. And finally, we'll end up with conclusion. Let's move on to the next slide. Introduction to SDT. What is an syntax directed translation? Syntax directed translation is a technique used in compiler design. It performs the translation based on grammatical structure of the programming language. Semantic actions are attached to production of a context-free grammar. These actions are executed during the parsing. SDT helps the compiler generates the intermediate code, type information, symbol table entries, mission level instruction, and the basic idea is grammar plus semantic action, which gives the syntax directed translation. I hope you guys understood. Let's move on to the next slide. What is an assignment statement? An assignment statement is used to assign the value to an variable. The general form is identifier equals expression. For example, A equals B plus C. Here A is a variable that receives the results. This is called as left hand side. The equal to the symbol is an assignment operator. B plus C is the right hand side, which is the expression whose value needs to be calculated. The compiler must evaluate the right hand side first and then assigns the value or the result to the left hand side. I hope you guys understood. Let's move on to the next slide. Why do we need SDT for assignment statements? Consider the statements A equals B plus C into D. The compiler cannot simply process these from left to right. It has to understand the multiplication has higher precedence than addition. It first calculates C into D, then it calculates B plus result, and finally it adds the result to A. STT allows us to associate these translation operations with the grammar. It can also help with the type checking and intermediate code generation. Therefore, SDT provides this systematic way to translate the assignment statements. I hope you guys understood. Let us move on to the next slide. Basic grammar for assignment statements. Now let's look at the grammar used for assignment statement. We have the production, yes produces ID equals E. This means the assignment statement consists of an identifier, an equal sign, and an expression. The expression can contains the addition, multiplication, parentheses, identifiers, and numbers. For example, A plus B into C is represented using the grammar. The important thing here is grammar separate expression into a E, T, and F. E represents the expression, T represents the term, F represents the factor. The multiplication is handled at the T level while addition is handled at the E level. Therefore, the multiplication gets higher precedence than addition. I hope you guys understood. You can check with the meanings. Let us move on to the next slide. Adding semantic actions. Now we had the semantic action to our grammar. This is where the actual translation takes place. For example, yes produces ID equals E. You can see E produces E1 plus T. We create a new temporary variable and generate the code for the addition. Suppose we have A plus B. The compiler can generate T1 equals A plus B. Here T1 stores the result. Similarly, for the multiplication, T1 equals B into C. The function newtemp creates a new temporary variable. The generate or emits function produces the intermediate code. So the semantic action tells the compiler what to do after recognizing the particular grammar rule. I hope you guys understood. Let's move on to the next slide. Understanding the place attributes. The place attribute is used to identify where the result of an expression is stored. For example, consider A equals B plus C. The compiler generates T1 equals B plus C. Now the result of an expression is stored in T1. Therefore, E dot place equals T1. Then the assignment action generates A produces T1. So the place attribute tells us where the value of an expression can be found. So the important function is new temp, which creates the new temporary variable, generate function, which produces the intermediate code instruction. I hope you guys understood. Let us move on to the next slide. SDT for arithmetic expressions. Let's take an example. A equals B plus C into D. According to operator precedence, the multiplication must be performed before addition. Therefore, the compiler first generates T1 equals C into D, then T2 equals B plus T1, finally A equals T2. This is the important example because it shows how a grammar itself helps to determine the order of a translation. The final three address code contains the three instructions. I hope you guys understood. Let's move on to the next slide. Step by step SDT example. Let's take another example. X equals A plus B into C. First, we evaluate the multiplication because multiplication has higher precedence. So we generate T1 equals B into C. Then we add A. T2 equals A plus T1. Finally, we assign the result to X. X equals T2. Therefore, the final intermediate code is T1 equals B into C, T2 equals A plus T1, X equals T2. This demonstrates how SDT translates an assignment statement step by step. I hope you guys understood. Let us move on to the next slide. Parse tree representation. This slide shows the parse tree for X equals A plus B into C. The parse tree representation, the parse tree represents the syntactic structure of the statement. Notice the multiplication operation is deeper in the tree than the addition operation. This represents the fact that B into C must be evaluated before A plus result. Therefore, the parse tree helps the compiler to understand the correct structure and order of an operations. I hope you guys understood. The observation is the multiplication B into C is evaluated before the addition. Syntax tree for assignment. Here we have simplified syntax tree. The root is assignment operator equals. On the left side, we have X On the right side, we have addition operation. The addition has A as one operand and multiplication as another operands. The multiplication has B and C, its operands. So the tree represents X produces A plus B into C. The next slide is type checking using SDT. SDT can also be used for type checking. For example, int A, int B, A equals B plus 10. This is the valid because both sides are compatible integer values. But consider int A, string name, A equals name. This is the invalid because we are trying to assign a string value to an integer variable. The semantic action can compare the type of left hand side with a type of the expression. If they are incompatible, the compiler reports the type error. I hope you guys understood. Type conversion in assignment. Sometimes the types are different, but assignment is still allowed through type conversion. For example, float x int y, x equals y plus 10. The expression produces an integer result. Since x is a float, the compiler can convert the integer result into the floating point values. The intermediate code can look like T1 equals y plus 10, T2 equals int to float T1, x equals T2. This process is called as type conversion or coercion. Let's move on to the next slide. Intermediate code generation. One of the major uses of SDT is generating the intermediate code. Consider A equals B plus C into D. The compiler generates T1 equals C into D, T2 equals B plus T1, A equals T2. This is called as three address code or TAC. Each instruction generally contains an operator and operands with a result stored in the temporary or variables. Intermediate code is useful because it provides a representation between the source program and machine code. It also makes the optimization easier. I hope you guys understood. Let us move on to the next slide. Another worked example. Let's consider result equals a plus b into c. Here is the parenthesis have the highest priority or top priority. So the first we calculate a plus b t1. Then we multiply result by c. T2 equals T1 into C. Finally, we assign the result. The result equals T2. Therefore, the final three address code is T1 equals A plus B, T2 equals T1 into C, result equals T2. Therefore, the final three address code is T1 equals A plus B, T2 equals T1 into C, result equals T2. This example shows how parentheses can change the order of evaluation. I hope you guys understood. Let us move on to the next slide. Complete STT algorithm. Let's summarize the translation process. First, the compiler passes the assignment statements. Second, it identifies the left-hand side variable. Third, it translates the expression on the right-hand side. During this process, the temporary variables are created for intermediate results. The compiler follows the operator precedence while generating the code. It can also performs the type checking. Finally, the result of an expression is assigned to the destination variable. So the overall process is source program, which produces the lexical analysis. Then it produces a syntax analysis, which produces the syntax directed translation that produces the intermediate code. I hope you guys understood. Examples with semantic action. This slide shows how a semantic actions can directly attach it to grammar productions. For example, E produces E1 plus T as an action that generates the temporary variable and generates the addition instruction. Similarly, T produces T1 into F, which creates the temporary variable and generates the multiplication instructions. For an identifier, F produces an ID. The place of the factor is simply the identifier itself. For a number, F produces num. The place is the value of the number. Therefore, each grammar rule has the corresponding translation operation. I hope you guys understood. Let us move on to the next slide. Advantages of SDT. There are the several advantages of SDT. The first is integrates the semantic processing with parsing, automatically represents the grammar structure, supports the intermediate code generation, helps in type checking, simplifies the compiler implementation, supports the syntax tree construction, generates the temporary variable systematically, provides the clear connection between syntax and semantics. I hope you guys understood. Let us move on to the next slide. Application of SDT. SDT is no limited to assignment statement. It can be used for expression evaluation, type checking, syntax tree construction, symbol table management, and intermediate code generation. It is also useful for translating the control flow statements such as if, while, and for. Therefore, STT is an important technique for different passes of the compiler construction. I hope you guys understood. Let us move on to the next slide. Conclusion. To conclude, syntax directed translation associate the semantic actions with the grammar production. Assignment statement SDT helps the compiler to evaluate the right hand side expression and assigns the final values to the left hand side expression. It also helps to maintain the operator precedence, performs the type checking, and generates the intermediate code. For example, x equals a plus b into c is translated into T1 equals B into C, T2 equals A plus T1, X equals T2. This shows how an high-level assignment statement can be systematically converted into an intermediate instruction. Temporary variable stores the partial computations. Operator precedence determines the order of an generated code. SDT can perform type checking and type conversion, and final output can be represented using the 3-address code. I hope you guys understood. If you have any doubts, please raise your doubts in the comment box so that I can respond. If you found this video is helpful, please subscribe to my channel, like this video and leave a comment below. Thank you.